Alright, how are you doing? Are you ready to answer some bearings questions? Seeing as it's almost exam time. Then let's do it!
It's time for Maths with Mr. Thomas.
This is Chapter 7, Lesson number 12. It is the second of the bearings lessons. Check that you understand that first lesson with bearings. Make sure it makes sense before moving on. The previous lesson was just calculating a bearing from one point to another, but no trigonometry was involved. Now you are hopefully an expert with that. We can move on to slightly trickier questions where bearings and trigonometry meet. Boom, 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 boom. The way I have worked this lesson is I have made 4 examples. They are just on the usual coloured backgrounds, but I have also, after each example, changed the numbers ever so slightly and given you a question. Same question, different numbers, to see if you can manage that on your own. I will give you the answer for that and just some very rough working, but it might be quite a good idea to watch the example, check if you can do it, make sure it makes sense, and then pause the video when you look at the question. Try that on your own and see if our answers match. As I said, 4 examples with 4 questions at the end. But let's begin! What is this all about? Well, now you're hopefully an expert with bearings. We can move on and apply trigonometry to answer some of these questions, as it says there. So example 1. A ferry and a trawler receive a request to help a stranded yacht. Help me, help me! The ferry is on a bearing of 234 degrees from the trawler. Calculate the bearing of the yacht from the trawler. Woo! And we've got this little diagram to help us. Oh, what a lovely diagram. So, F is the ferry, Y is the yacht, and T is the trawler. Well done. We can see we are told the ferry is on a bearing of 234 degrees from the trawler. What does it mean from the trawler? Oh, that's the whole Christmas card thing. In the last lesson you were saying that if we got a Christmas card from Care, then that's where it would start. The Christmas card would start with Care. So if the bearing is from the trawler, that's where we're starting. That is perfectly right. Yeah, well done. Look, you are right. Which means then, because it's from the trawler, if you start at the trawler with your north line, then you can see it is 234 degrees round to the line that points towards the ferry. The ferry is in a bearing of 234 degrees from the trawler. What do we want to find though? Lucy, help us.
Oh, we're wanting to find the bearing of the yacht from the trawler.
You're right, yeah, we want the bearing of the yacht from the trawler, and once again it's those words, from the trawler. Bam, 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 bam. So, we are wanting to go from north, and we're wanting to go from the trawler. That's where we start. And we want to find the bearing round in a clockwise direction. Keep going past east, past south, past this line that is pointing towards the ferry, and we want to keep going and find out what that bearing would be from north right the way around to this line that points towards the yacht. So, to do this, how can it be done? Can anybody help me? Avery, what are you thinking? You're right, yeah, we already know the bearing from north around to this line that points towards the ferry, and because we're wanting to find the bearing from north around towards this line that points towards the yacht, the only thing we need to know is work out this angle for the triangle. We need to know that angle right there. So, this is a trigonometry question. It is a probably right-angled triangle. So, we have all 3 sides and we want to work out this angle.
Oh, when you have all 3 sides, it's a cosine rule. Because if you have all 3 sides, or you know 2 sides and the angle between them, it's the cosine rule.
Darren, you're right, yes. And because it's an angle we want to find, then it's the cosine rule to work out the angle, which is given on the formula sheet. Remember, in the formula, the lowercase letters represent the sides, and the capital letters represent the angle. So, this is the angle we are wanting to find. We want to find that angle, and we know all 3 sides, so this here is going to be our A. So we can start off writing down that our cos A equals, or because it's from the trawler and we've got this point T here, we could say cos T equals. If this is T, then across from that is going to be your small T. Or if you imagine it just with the formula, that there would be your A, because it's the only capital letter in the formula, which means that there would also be that small a. Think about it whichever way you like. The B and the C in the formula are just going to be the other two sides. So the B and C are going to be the 20.6 and the 15. So we would have the 15 squared add 20.6 squared, or the other way around, but we are definitely going to be taking away the 18 squared. That's the one we take away. We divide that by 2 times b times c. Again, b and c are the sides either side of the angle, so 2 times 15 times by the 20.6. It means then cos t works out to be the 325.36 over 618, which gives us 0.526 blah 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 blah. That is cos t, but we don't want cos t. Moksha, what do we do to get t?
We do cos to the minus 1.
We do, yes. So to get t just on its own, you do cos to the minus 1. So cos to the minus 1, inverse of cos of that 0.526. Again, keep that answer really accurate on your calculator. Don't just do cos to the minus 1 of 0.5. Keep that answer. Cos to the minus 1 gives us 58.23 degrees to a couple of decimal places. So that is going to be the size of this angle right here. Once again though, we want the bearing. So from north around to here is going to be 180 around to south. But we know around to here it is going to be 234. It's the size of that angle from north around to this line. But if we add that bit on, we will get the bearing around to that line that points up towards Y. We will get the bearing of the yacht from the trawler. So we take that 234 and we add on our 58.23.
Oh, wait a minute. We could just add 58.
You can. Why can you just add 58?
There's 3-figure bearings. You don't really use decimals, so you put it to the nearest whole number.
You're right. Yeah, well done, Colin. You would just do the 234 add on, and that goes to 58 to the nearest whole number. So it's 234 degrees. Add on the 58 gives you 292 degrees. Woo! So that is going to be our bearing. As I said, 3-figure bearings, they're always written with 3 figures. Here is the first question then for you to try on your own. Pause this video, try working your way through it. It's the exact same as the previous example, except I have changed the numbers. Pause the video, and then once you are ready to have the answer revealed, and some very rough working, you can see if you get it right. Good luck! Have a good time. Whatever. Pause the video. Okay, so let's see how you got on. First of all, the answer is 297 degrees. Hopefully you managed that, but if you didn't, what you want to do is just work out the size of this angle. So it is, once again, same as example 1, the cosine rule. Make sure you are taking away the 12 squared, because in the cosine rule it's cos A equals, so this here is really our A, which means across from that is our small a. So these are the B and C in the formula. Make sure you're taking away the 12 squared. So 16 squared at 10.3 squared, take 12 squared, divided by 2 times 16 times 10.3. If you work that out to a decimal, you end up with 0.66168, blah, 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 blah. Do cos to the minus 1 to get the size of that angle, and once you have that angle, round that just to the nearest whole number, so 49 degrees. So do the 248, add on the 49 degrees, and it gives you the 297 degrees for your answer. But you managed that. Well done! Do you want to try another one? Let's do it! Example 2. 2 ships leave Dundee at the same time. Ship A sails east at an average speed of 9 kilometers per hour, while ship B sails in a bearing of 142 degrees at 10.3 kilometers per hour. How far apart will the ships be after 2 hours? So, for this one, sometimes you are given a diagram for it, sometimes you are not. What you want to do though is, before I reveal the diagram, you want to picture just a starting point. That can be the port, that there can be Dundee. Lovely place. And the ship A is sailing east. So there is east, there is north. You could always just imagine your north line drawn in, so there's north. You know it's sailing east, and it's sailing at an average speed of 9 kilometers per hour. And ship B sails in a bearing from north around 142 degrees, which is maybe around about there somewhere. at 10.3 kilometers per hour. And then you want to know how far apart they are after 2 hours. So your diagram should look something like that. You've got the right angle there between north and east, because between north and east it is 90 degrees. That there will be ship A. And down here, for the bearing of 142 degrees, that will be ship B. We want to work out how far apart they are, but what's the first thing that you have to do? John, do you know?
Oh, I do know. I know that what you do is you take the speed and you multiply it by 2.
And why do you do that, John?
Because it's 9 kilometers per hour. So it means each hour they go 9 kilometers. So after 2 hours, it would be 9 kilometers for the first hour, another 9 for the second. Shows ship A has gone 18 kilometers.
Well done, John. Yeah, you're right. Which means if you apply that, Calissa, how would you work out ship B, how far that's gone?
Well, you could do the 10.3 kilometers. That will be the first hour. And then the second hour is another 10.3, which means ship B will have been 20.6 kilometers.
Well done, Calissa. Good. So, we know the distances here. The size of this angle. How would you work out the size of this angle between them? What would you do with that, Jenna? Yeah, well done. You know from north to east is 90. From north right the way around to this line is 142. So to work out the distance between them, between east and the 142, just do the 142, take away 90, which means that angle there is 52 degrees. To work out the distance between the ships, once again, it's bearings, but we have a triangle. It is a non-right angled triangle. So we are going to have to apply either the sine rule or the cosine rule. But which one's it going to be?
Well, first of all, think of the cosine rule, Mr. Thomas.
Okay, so I'm thinking about the cosine rule. What about it?
Well, you use the cosine rule if you know all 3 sides.
Do you know all 3 sides of this triangle?
No, you don't. Or you use it if you know 2 sides and the angle between them.
So do you know 2 sides and the angle between them? Yes, well done, Jacqueline. So that there, it would be 2 sides and the angle between them. So you can apply just your cosine rule. And the cosine rule to work out the length of a side is a squared equals b squared plus c squared minus 2bc cos a. Woo! And in the triangle, in the formula, the lowercase letters represent the sides and the capital letters represent the angles. So with this one here, we have this angle here is the 52, that side's 18, that side's 20.6, and this one here is what we're wanting to find. That is our missing side. So if we start with that, we are going to call this side AB, because it's the distance from A to B. So we can say AB squared would equal, B and C are just going to be the other 2 sides. So we've got the 18 and the 20.6. So we have 18 squared at 20.6 squared minus 2 times the 18 times by the 20.6 times by cos of our angle, and this angle is 52. Put that into the calculator, boop, 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 and you end up with 291.785. That is going to be the length of AB squared. So that's there, AB squared. How do we get AB then?
You can square root it.
We do, we square root it. Good, well done, Greg. So if you square root that, we will get AB, which is the square root of the 291.785. Again, keep that answer on your calculator, make sure it's super accurate, and you end up with 17.8 kilometers. Which means then, if that is the length of that line between A and B, it's the distance between ships A and B. So we can say, therefore, the ships will be 17.08 kilometers apart after 2 hours. The end. Well done, yes. Do you want to try one very similar to it and see if you can do it on your own?
Yes, please.
There you go. There is question 2. See if you can do that. It is very, very, very similar to the last question. See how you get on. It's just the exact same with different numbers. See if you can do it. Pause the video now. You've still no paused it. Pause it. Pause it. Come on. Well done. Okay, let's see how you got on with that one then. So, The two ships leaving Liverpool at the same time. One travels northwest at an average speed of 10.05 kilometres. Other one travelling at an average speed of 14 kilometres and a bearing of 280 degrees. First thing you have to do is you have to picture what that looks like, and you should hopefully have something that looks like this. You've got one ship going at a bearing of 315 degrees, because northwest is 315 degrees. It's halfway between the 270 and the 360. And the other ship is on a bearing of 280 degrees. To work out the size of the angle between them, hopefully you did 315 take away 280, which gave you the size of that angle as 35 degrees. Also, for the distances, it tells us it's 10.5 kilometres per hour. So 10.5 kilometres per hour means in 2 hours you go 21 kilometres. And for the other one, for the 14 kilometres per hour, means in 2 hours it'd be 28 kilometres. So if you ignore the whole bearings part, basically you've got that triangle and you want to work out that missing side. You want to work out the length there. To do that, again, cosine rule. If you know all three sides, or if you know two sides and the angle between them, which you do here, so you can apply the cosine rule. So it's the x squared would equal 21 squared add 28 squared minus 2 times 21 times 28 times cos 35. Work that out and you end up getting x, the missing length, to be the 16.18 kilometres, which means you can finish that off with a sentence saying the ships will be 16.2 kilometres apart after 2 hours, or 16.18. Always give your answer to 1 or 2 decimal places unless you are asked otherwise. But that is your answer. Woo! Hopefully you did well. You did? Hey, you're amazing at this! Awesome! Example 3. A and B represent two forest lookout towers. Ba-ba-ba-bam! A is 5 kilometres and a bearing of 210 degrees from B. And a forest fire is sighted at F. Ba-ba-bam! On a bearing of 78 degrees from A and 140 degrees from B. A firefighting helicopter leaves A for F. What distance does it have to travel to reach the fire? So if the firefighting helicopter is going from A up to F, that is our missing side. That is what we want. So this question here is slightly trickier than the previous ones, but the first thing I would do is to start filling out as many angles as you can. Can anybody suggest any angles?
Oh yeah, that one at the top. Just up there. Yeah, that one there. That's going to be the 210 right the way down to that blue line. Take away the 140 to the first blue line. So if you take them away, you will get 70 degrees.
Yeah, you're right. Yeah, so this angle at the top is going to be 70 degrees. Well done. Anything else you could work out? Good, yeah. You've got a Z shape there. There is north coming down to this line. It jumps across to this point and then heads south. That's our Z shape, which means if that there is 78, then this bit here will also be 78 degrees. Good. Anything else you could work out? Yeah, good. You could really, with this 70, you could split that up. Don't just half it. There's nothing to say that it's halved. But we know it's 140 degrees to this line. If we keep going to 180, we'd have to add on another 40. So we know this wee angle in here is going to be 40. But that again gives us a Z shape. So we've got this line here coming up to this point. Then it's jumping across here and then going north. So we've got our two parallel lines joined up with another line. So if this angle here is 40, this one here will also be 40. How does that help us? Yeah, good. You could work out the size of this missing angle. If you do the 40, add the 78, and then take it away from 180, what does that give you? 62 degrees! Well done, good. So that there is 62 degrees. Brilliant. Anything else you could work out? Yeah, I suppose if you know this angle 70, then you can split that up, so that there would be the 30. You can split that, I suppose. Does it help you much? No, not really. Let's write this slightly neater. That is all our angles there. That's what we're wanting to find. This length from A to F. We've filled out all our angles, so now we've filled out the angles, we can start to apply trigonometry. So, first of all, we think about the cosine rule, and you know use cosine rule if
You know all three sides are two sides and the angles between them.
So do we know all three sides?
No.
Do we know two sides and the angle between them?
No.
So if we can't use the cosine rule, we use sine rule. Good. And for the sine rule, you think of pairs. Good. So we are wanting to find this side. So this side has to be used along with its pair. Its pair is the angle across from it. And the angle across from that would be that 70 degrees. What other pair do we use? Yeah, well, we can't use the 78 on that side because we don't know what this side is. We've no idea about it. So we can't use that, which means we have to use this 62 degrees and the 5. If we use that, that is another pair that we have. So to answer this, I would just ignore all the north lines, ignore all the other angles. Just know that is 70 degrees. The side across from that is what we want to find. That's the missing one. We have this angle here and we have this side across. So we can apply the sine rule. Just remember the sine rule, A over sine A equals B over sine B equals C over sine C, and we want to look for our pairs. In the sine rule, lowercase letters represent the sides, capital letters represent the angles. Because it is a side that we want to find, you can see here the side is on the top, and if you want to work out a side, use the formula with the side on the top. If you want the angle, flip it upside down so it becomes sine A over A equals sine B over B equals sine C over C. But it's a side we want, so we leave it as that. We start with what we want to find. So the side, well, because that is capital B, this here is going to be small b, so we can just call it small b, or you could call it a f if you want, from A to F. Call it whatever you like, call it X. But this side here is going to be paired up with this angle, and you can see it's going to be A over sine of the angle, so it's going to be B over sine 70. And that would equal, well, the other pair is the 5 and the 62. The side goes on the top, so we would have the 5 over, and you can see the capital letters, the angle is paired up with sine, so it's going to be sine of the 62. We want to get B just on its own, so to get B just on its own, we get rid of the divide by sine 70. So what is the opposite of divide by sine 70? Times by sine 70. Good, so you multiply over here by sine 70, and when you multiply, it just goes on the top. So the 5 stays where it is, the sine 62 stays where it is, and we just put a times by sine 70 up there. If you work that out on your calculator, you end up with B being 5.32 kilometers. And yeah, it's the answer. It says, what distance does the helicopter have to travel to reach the fire? Well, that's the distance from A to F, which we just worked out. So you can finish it off and say, therefore, the helicopter will have to travel 5.32 kilometers to extinguish the fire and save the lives of all the doggies and hamsters. Yeah, that is your answer. Do you want to try one similar to it and see if you can do it on your own? Yes, please. There you go then. There is a similar one. Once again, pause the video here and see if you can do this just on your own. I'll give you the answer once it is unpaused. Pause it! Okay, so how did you get on with this one then? The answer, I will give you that straight away to see if you can see if it is right. The helicopter has to travel 8.59 kilometers. Did you get that? If you did, awesome! If you didn't, I will talk you through it ever so quickly. So, first thing is A and B are the two forest towers. A is 9 kilometers and a bearing of 220 degrees from B. Forest Ferry is sited at F and at a bearing of 70 degrees from A and 150 from B. See, when you're going through this, what you should be doing is filling out something that looks like this. So we've got A, we've got B, we've got F, we've got the size of that angle there. F is in a bearing of 150 degrees from B, and A is in a bearing of 220 degrees. So you've got the size of that angle. We know the distance between them, the difference between them, between the 220 and the 150 would be 70 degrees. We could also write down that that's 30 and that's 40. It doesn't really matter which way you are writing it. We are also told, what else are we told? We're also told that the forest fire is sited at F on a bearing of 70 degrees from A. So from A, from north around to here, that's 70 degrees. But if you use your Z shape, from north up and then down here, so these lines are parallel, because this is 70 degrees here, this will also be 70 degrees. So you could also write that in. We know that this wee bit here is 30, so if you go from the south up to that point, then across and then north, because this bit's 30, it's the 30 degrees less than 180, which would go from north to south. Because this is 30, this is also 30, which means because you know this angle and you know this angle, well, from north to south is 180, so do 180, take away the 70 and the 30, and it means that there would be 80 degrees. So you can fill that out. If you start to ignore everything outside of the triangle, apart from the lengths, what you end up with is a triangle that looks just like that. Where you're wanting to work out the length of that side from A to F, you know that there is the 80 degrees, you know it's 70 degrees at the top, it was the 40 and the 30, and we know that's 9 kilometres. We can then apply the sine rule because we know that angle and we want the side across from it. And we know this angle and we know the side across. Once again, use the cosine rule if you know all three sides, or two sides and the angle between them, which you don't, so it is the sine rule. If you start writing the sine rule out then, you would have x over sine 70 would equal the 9 over sine 80. And to get the x into its own, multiply both sides by sine 70, so you end up with 8.59 kilometres, or 8.6 kilometres, do it to one or two decimal places, makes no difference, but that is very quickly how you would do that. If you're still unsure about the question, look back to example 3, where I'll talk through it in a lot more detail, and then maybe try that once again on your own and see if you can do it. Good luck. What, you didn't need that? You got it on your own? Oh, you're amazing at this. Well done. You are so ready for this exam. Well done. Last one, example 4. A ship leaves port on a bearing of 75 degrees and it sails 27 kilometres. The ship then changes course and sails a further 20 kilometres on a bearing of 131 degrees, where it anchors. When it anchors, it is 41.63 kilometres from the port. Calculate the bearing of the port from the ship at this point. So, what is it we actually want to find? Well, we wanted the bearing of the port from the ship. So, from the ship means we are starting at the ship. This is where we're starting, and we want the bearing of the port, which means we are going from north right the way around, whee, until we hit the line that is pointing in the direction of the port. So we want from north around to this line. So how do we go about doing that?
Well, what we're told is that there's a bearing of 131 round here, which means if you make a Z shape, whoop, 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 that there of 131, if you jump over that there will be 131.
Good, that is going to be 131.
Which means you could always go from north to south. That's 180.
Yeah, and then...
Well, from south around to that line there that jumps across to this bit, that angle there will be the 131 because it's an alternate angle. It's a Z shape. And then you can do 180, add the 131, and then just take away the size of that angle in the triangle.
Perfect, yes, that is one way to answer that. That is absolutely perfect. So you can always ignore everything outside of the bearings, outside the triangle. You could ignore the north lines and all these angles and so on, and just start by working out the size of this angle. How do you go about working out the size of that angle then?
Well, you could always just use the cosine rule because you know all three sides.
Good. So, use cosine rule if you know all three sides, and here we know all three sides. So, in the cosine rule, we have cos A equals b squared plus c squared minus a squared over 2bc. Notice how this a is the only capital letter, which means in the formula it's the only angle we have. This is the only angle we are wanting to find when we're working this out, which means this is going to be our angle, which means this here is going to be our a. And if that's a, then it means across from that, the side that that's not touching is going to be your small a. So, we are going to have cos A equals B and C are just going to be the other two sides, 41.63 and 20. So I've got 41.63 squared at 20 squared, take away the 27 squared. Make sure it is the 27 you are taking away. If it's not the 27 you're taking away, you're making a mistake. Then divide by 2 times b times c, so 2 times 20 times by the 41.63 in any order you like. And if you fire that into the calculator, you end up getting a decimal of 0.8431 and so on. That there is cos A though. We don't want cos A, we just want A. So how do you go about getting A on its own?
Cos to the minus 1.
Good, so cos to the minus 1 of 0.8431 ... And if you work that out in the calculator, you end up with 32.52 degrees. Woo! So, it means that we know from north around to south is 180. So we can say that's 180 degrees. We also know from here around to this line is 131. because of the Z shape. That's 131, so that there is 131. So we can do the 180, add the 131, but then we want to take away the size of that angle in the triangle. So we're taking away the 32.52. And remember, it's bearings we're working with, so instead of giving our answer of 278.48, we would just write it as 278 degrees. So again, it is 3-figure bearings. We don't need the decimal, so just keep it as that. Woo! So that will be our answer. I should point out as well, there is a different way to answer this question for anybody that is wondering, for anybody that has noticed it. You could always form a Z shape here. And if you form a Z shape there, then it means this angle is going to be 75 degrees. And if you take the 131 away from the 180 from north to south, and it means this angle here then is going to be 49 degrees. And if you add them together, the 75 and the 49, you could work out the size of that angle. And if you work out the size of that angle, you could use the side across from that, and then it means you could actually use the sine rule to answer this question. Because you want to still work out the size of this angle, so that could be paired up with the 27. So you could do sine A over 27 would equal sine 124, the 75 at the 49, over the 41.63. So you could always use the sine rule to work that out. If you do, you still get the 32.5 degrees, and you're still wanting to add the numbers together and then take away the size of this angle. Or another method again, you could always use the sine rule to work out the size of this angle, and then once you've got that, you've got the 75 and this angle, and then you would have your Z shape there. And if you use the Z shape, then that angle there is going to be the bearing from north around to what you want to find. So you can just add it to 180. So there's a few different ways of solving that, just in case anybody is wondering. There you go, there is a question like it. It is very, very similar, just with different numbers. See how you get on answering this. Once again, pause the video now and see how you get on doing it just on your own. Good luck. Woo! So, how did you get on with it? Did you get an answer of 278 degrees? Hopefully you did. If you didn't, here is very roughly how it is done. You are needing to work out that this angle here is 140, which means that this angle here is also 140. So if your final answer, you do the 180, add the 140, and then take away the size of this angle. And to get the size of that angle, you're going to be using the cosine rule. Well, that's one way of doing it. If you use the cosine rule, because this angle is what you want to find, that's your cos A. That there, the 50, is your A, which means when you apply the cosine rule, you would have cos A equals the 37 squared, add 70.8 squared, take away the 50 squared, work that out, and get 42.19 degrees. You could always just write that as 42 degrees because the bearing is just going to be a 3-figure bearing, so it's just 3 numbers, ignore the decimal, so really it's 42 degrees. So you can do the 180 from north to south, add the 140, which is that Z shape there, and then take away the size of the angle in the triangle. And if you do that, you end up with 278 degrees for your answer. Hopefully you managed that though. Woo! Well done! That is 8 questions. 4 of them I'm talking through in a lot of detail. 4 of them I've just given the solutions, but hopefully you're a lot more confident with bearings. Try some of the questions in those bearings worksheets that I've put on Teams. Best of luck. See how you get on answering these when you're working out the bearing from one point to another, but applying trigonometry. Woo! Can you do it? Yes, you can! Woo! See you later.